What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to learn how to factorize an expression, and this is kind of like the opposite of expanding that we've been doing in the last couple of lessons. This is a little bit more difficult, but if we get the correct scaffold, the questions become a lot easier. The first thing that we've got to talk about is, what does factorization actually mean? What we're looking for when we say, hey, factorize this term, is we are trying to find the factors or the multiplication that allow that number or that expression to exist. I know that sounds a little bit weird, but it's pretty simple when we break it down. For example, if we're just looking at the number 6, we'd be like, hey, can you factorize this or find the factors? What we mean is what numbers multiply to 6. So we'd have 1 times 6 and 2 times 3. These are the factors that make up that value 6. So we're looking for the multiplication things that give that final answer. Then if we've got something like 6a, we know that that's 6 times a. But if we're looking for the factors, it could be 2 times 3 times a, or just 6 times a. Both of these would be a factorized version of the 6a. Then if we've got something like 6ab, our factors for this would be 2 times 3 times a times b. Each individual one of those would be the factors that make up that term 6ab. So the way that this becomes like our brackets and our expanding is when we've got two terms. What we're trying to do for this thing is to find the highest common factor between these two terms and see if we can make a multiplication that would give the same answer if we multiplied it out. So what we're looking for, two terms, find the highest common factor. So if we had something like 2x plus 6, the highest common factor between these would be 2 times x, that gives us 2x, and 2 times 3, which gives us the 6. So the common factor between these two terms is just 2. So for this next one, I have 6a plus 18. This one can get a little bit more confusing because you go, oh, 3 is a common factor of both of those. 2 times 3 is the 6, and then 3 times 6 is the 18. But we're not looking for a common factor. We're looking for the highest common factor. So between these two, it would be the 6, because 6 times a, 6a, and 6 times 3 gives us the 18. So finding those highest common factors is really important. What we're going to try and do after we've found that highest common factor is recreate the expression with brackets and the highest common factor being the multiple that we put out the front. We've seen that, hey, that term out front of the brackets multiplies with both values. We're trying to get exactly to that point, but by removing the highest common factor. So another way to think about this is factorization is the opposite of expanding. So if you're already great at expanding, that's awesome. We're just trying to get back to that position. We want an answer with a value out the front, usually a number, and then brackets with two terms in the middle. We want to be able to do that expansion and get the same result, because we're doing the exact opposite thing. Almost like plus and subtraction, factorizing and expanding are complete opposites of each other. So if I've got 4x plus 8, I've got to make an expression with brackets. I always put the brackets in because that's what my answer's got to look like. Out the front is where I've got to put my highest common factor, and whatever's left over, I'm going to put in the brackets. Between 4x and 8, the highest common factor between these two values is 4. So I'm going to put a 4 out the front. So inside the brackets, we've got to leave what's kind of left over. What I mean by left over is the 4 is being divided out of both of those terms. 4x and 8 is getting a 4 divided away. So once I've divided the 4 out of the 4x, all that's left is x. And once I've divided the 4 out of the 8, all that's left is plus 2. A really good way to check if you've got these ones right is we could actually expand it. It's the exact opposite. So I could do 4 times x, 4x. 4 times 2 is the 8. Now I'm at the same spot, 4x plus 8. So that's how I know I got this factorization correct. Another example, I've got 9x plus 12. Again, I'm looking for the highest common factor to go out the front of these brackets. The highest common factor between 9x and 12 is 3, so that 3 is going to go there. Now think about, I'm dividing both of these terms by the 3. 9x divided by 3 is equal to 3x, and 12 divided by 3 is equal to 4. So my final answer is 3 bracket 3x plus 4. This even works if the x isn't that first term. So for this one, I've got 7 minus 14x, and the common factor between 7 and 14 is just 7. So again, that 7 is going to go out the front. 7 divided by 7 is just 1, so that goes there. And then negative 14x divided by 7 is negative 2x. Sometimes you might see people always taking a negative to leave a positive x value, but for this lesson, this is going to be enough. Again, to make sure that we got it correct, we can do an expansion. 7 times by the 1 is 7. 7 times by negative 2 is equal to negative 14. Throw the x on. That's exactly the same as what we had in our first line, so we know that we got it correct. So if we have two negatives, so negative 2x minus 6, we're going to take out the negative factor that goes into both of these things. So just look at the 2 and the 6 to start off. The highest common factor between those two is 2, but because both of them are negative, I'm going to remove negative 2 out the front. That's my highest common factor. So now I've got negative 2x divided by negative 2, which is just the x, and then plus 3, or negative 6 divided by negative 2 is just that plus 3. Anytime we do have these negatives, I would highly recommend doing the expansion afterwards just to make sure you got it right. Negative 2 times positive x, negative 2x, negative 2 times plus 3 is equal to negative 6, so you know you got it right. Finally, this works even if we've got letters in both of the terms. So here we've got 3a squared minus 12a. The highest common factor between these two terms is not just 3, it's actually 3a. That's because if we think about 3a squared, that's 3 times a times a. And then if we think about the negative 12, that's 3 times 4 times a. So 3 times a is the highest common factor between the two of them. That means the 3a goes out the front and we're left with a negative 4. Again, I would highly recommend doing your expansion afterwards, but 3a times a, shocker, is 3a squared, and 3a multiplied by negative 4 is equal to minus 12a. So that's how we know that we got these ones right. Always look, if there's the same letter in both terms, you have to have a letter out the front because it's always going to be that common factor between the two terms. So the big thing about this lesson is always look for the highest common factor between the two values. Make sure that you throw those brackets down straight away because that is what your answer has to look like, and then take out the highest common factor and put it out the front. Again, I would highly recommend always doing your expansion afterwards to double check your work. But if you get that scaffold down, factor out the front, 2 brackets, I know you're going to do fine. Thanks so much for watching this lesson, and I'll see you later.